Hello, class. This is Brother Alvy. I just thought I'd help you out with assignment 3 this week. I hope all went well with assignment 2. This might help you with that as well. In assignment 2, you had to read some files and parse some lines. So if I just kind of walk through the main function with you here, we can remember what assignment 2 is supposed to have done. In assignment 2, we make a string and we get the file name. The file name function has a string variable. It asks the user for the name of the file, and it inputs the file and returns that file. So the string file here inside main should have whatever the user types in as their file name. That should be pretty straightforward by now. Okay, and then you were to make a list of access records. Access records are a struct, so that's kind of a new concept for this class. The struct is a way, it's kind of an object. It's a very simplified object. It allows you to group variables together into like some logical unit. So an access record helps us name 3 variables at once. We have a user string, a file string, and a time that's a long integer. So we can group those 3 things together using struct. And so every time we make an access record, each access record will have those 3 components. As it's its own data type is what it really is. Okay, so just like we have strings and integers, those are simpler data types, but we're creating our own data type using the struct, and it relates those 3 items together. And so we can create access record variables, and we can also create arrays of those variables, just like we can create arrays of strings or arrays of numbers. So we're going to call the name of this access record list or array, we're going to call it records. And again, we have the constant value max size defined. We've defined it as a constant integer. It's a good idea to name constants with all caps. That's the convention that you should use. Okay, so we have it set up so we can start storing access records. Then next we have an integer called record count, and we're going to read the file, and that will return the record count. So if we go to the read file function, if you finished assignment 2, it should look something like this. Okay. It has 2 parameters. We take a string and that list of access records, and we go through, we grab an ifstream, we create an ifstream variable. We've got to make sure we have the fstream included. And we create a variable called fin, and we use that file name that we asked for from the user. Now, the ifstream uses old school strings, so we have to convert that to a C string, the old C language, the grandfather of C++. That was in C. In the C language, they used character arrays exclusively. In C++, we're introduced to the string concept, but some of the older ways are still hanging around. Okay? In case you got stuck on that. We're going to go through the file. So the first thing we do is we check to see if the file is okay. We call the fail function. If there was an error opening the file, that should return true and say, hey, there was an error. And then we can deal with that and return from the function. Otherwise, in assignment 2, you're going to go through a while loop, and while the file was not at the EOF or end of file, it would keep looping through each line of the file. And then we were able to grab input directly from the file stream and input that directly into our access records list. So each access record at any given position, so count each time through the loop should have the same value. At any given position, it needed 3 pieces of data connected to that struct object. So the first one was .file. The dot allows us to access each of the members of an object, like a struct. So .file is going to be the variable inside the position count for that struct. And .user will be the user variable for that same position, for that same variable. And .time will be the third variable. So one position in that array accounts for one access record, and each access record has 3 variables it can access that make up that variable. Okay. And again, each time through the loop, we will check to make sure the file hasn't failed. Add to count so it moves on to the next record. That's how we did it in assignment 2. Okay, and don't forget to close the loop. Now this is going to be one of the major parts that we are going to be changing for assignment 3. So I'll just comment that out so we can remember it, but we're going to be taking that part away. So once we read the file and we get back the record count will return the number of records we have, or it will return -1 if there was a problem. Okay. You don't need to know about that. And then we're going to have 2 long integer variables, start time and end time. So time in computer land is the number of milliseconds since like 1970. And so those numbers get very large. So that's why we have to use long integers. Okay. And so we simply take some output, ask the user for the start time, and we'll input the big long numbers. I think we have files with these numbers in them. Yeah, good. And we will ask for the end time, and then we will display the results. We'll give it the records list, the record count, so we know how many times to loop, and the start and the end time. So in assignment 2, the display results function went in, and we just kind of styled things nicely. We put an end L, we put some output, following records match your criteria, and we use set W from the IOmanip library. Where is it? There we go. Display results. To help us with spacing to output that nicely to the screen. So we set width to 15, timestamp 20, file 20, user. Space it out nicely. And then each time through the loop, so the second variable size parameter that corresponded to the count that we collected. And so this for loop should go through the exact number of times for the records list. We go through the loop, and each time through the loop, okay, starting at 0, and hopefully you've got the for loop down by now, we're going to ask a question. If the start time that we've been given is less than the time in that current access record, and that current access record's time is less than end, So that means that this time is between the start and the end. Then we're going to display that record. We give it the record at position I. So that will be a single access record. And we display the display record. Is that not one of the functions we have? Boom, 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 boom. There it is. I was a little blind for a second. A good editor will help you jump through your functions a little better than just scrolling up and down, but that is what it is today. The display record also uses the setW function and spaces things out in the same way that we space things out for the titles. So 15, 20, and 20, and we space out. We take we're given a reference to that access record, so we can use record directly as a variable, and we know that each access record has 3 parts to it: time, file, and user, and we can output those just like variables. So that's what assignment 2 was doing. Now in assignment 3, you're going to be building on that. Okay. So now when we parse the file, we're going to be looking for a few of the problems. We're going to be looking to see if the timestamp is corrupted or not. We're going to be looking to make sure the timestamps are greater than or less than the current. Sorry, we don't want any timestamps that are too small, like less than 1 with 9 zeros, or any greater than 10 with 9 zeros, whatever those numbers are. Billions or whatever those numbers are. So what we want to do is we're going to change things up just a little bit. Okay. And inside the read file function. So I'm instead of parse file, I'm going to call it read file. Inside the read file function, I'm going to make my while loop a little bit different. Okay, so that's how we used to do it in assignment 2. This time I'm going to make a string called line. Then I'm going to jump into a while loop. But this time, as per the note in the assignment, I'm going to say while my getLine function, I send it the file variable and the line variable, the current line that I'm looking at. Or sorry, that's the new line that I just made. Okay. While getLine, and I put it into the string. Excuse me, I got mixed up there. Okay. I'm going to parse each access record, but I'm going to use the defensive programming. So I'm going to look for errors, and I'm going to use the try block, and I'm going to catch any possible errors just to make my code more resilient. So I'm going to use the try block that we've learned about. And in here, inside the try, I will create an access record. I'll call it record. And I'll set that equal to a call to parse line, which is a function I will make in just a minute. I've got the skeleton ready for that up here, and we'll see how we parse each individual line. Right now, I'm going to just, each time through the loop, I'm going to say, okay, I'm going to parse the line, And then in the records list, at the position count, just like before, I'm going to set that equal to the record that gets returned from the parseLine function. And again, I will add 1 to count using plus plus. Okay, so I'm going to try that. But there's a possibility that I could have an error, so I'm going to catch. And then I'll hopefully be able to get a message back if there is an error. Okay, and if there is an error, I will output the message that is sent. Okay, and this time I do not add to the count. Don't advance the counter. Okay, and I'll still close the file. Okay, so it's a little bit different while loop. I'm going to be going through and using the getLine function, and each time I'll put a new value into the string line. Okay, now I'm ready to actually parse the line. Okay, and this is the fun place where we get to use the other thing we learned about, the string stream. So you need to make sure to include what is it called? S-stream? S-stream. There we go. For string stream. And this will allow us to be able to make a string stream variable I'll call it SS, string stream. All right, and in that string stream variable, I have an str function, and I pass it my line string. That gives me the string that becomes my stream that's going to act just like the file or just like the C in and C out stuff, where it's the stream where I'm getting the input from the user. But instead of the user, I'm getting it directly from a string. Okay, so in here, I'm going to make a variable for an access record. Okay, we're going to read in the variables, and I'm going to assume everything works okay. So SS is the name of my stream. I use the stream operator. I take that record, start with the file. Okay, so the first part in that line, the first part of the string until it gets to a space, will be the name of the file, or the file variable from the struct. That's where I'm going to store that part of it. The next part of the string, up to the next space, gets recorded in the user variable for that record object. And the third one is the record for the time. Okay, so it's given a string with 3 parts to it separated by spaces, and we create a stream out of it, and because they're separated by spaces, calling this string 3 times will put each of those values from that single line into those 3 places. Okay, next we need to check for problems. If the string stream failed, okay, if the string stream failed, it meant that there was a problem with the data that was in the line. So the file or the time, possibly the time had characters in it, so it might have failed. Okay. Or if the time that we're given from the line, if that is less than a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, that's the lower limit. Or if the time is greater than 10 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That's the upper limit. So those are those checks that you have to consider from the description in the assignment. We have to make sure and check to make sure those things don't cause problems. So if they do, then we catch this and we're going to throw a string. Error parsing line space, and then we'll concatenate the line that we are currently looking at. So if the line fails somehow, or it's bad data, we're throwing an exception. Okay? We're throwing a string exception. So when you throw things, you have to catch them, right? So right there in the read file, when we put the parse line into the try block, if something gets thrown, that's when the catch will be initiated. And the string will be the message that we send through the throw command. Okay. The last thing to do in parse line, it has to return an access record. So we have to make sure to return the record. Let's run that and see how many errors I have. Oh my goodness, it's working. Good thing I prepared for this ahead of time. All right, enter the access record file. Now I have a bunch of test files. I'm just going to test this on this simple data right here. Okay, I have a few that will probably throw errors. One's got a time that's way too small. One's got a time that's way too big. We'll see how that goes. All right, so I'll put in my file name, assign03a.txt. That's the name of the file. Okay, and so there was 2 errors. It had an error parsing the first line. We knew that one was going to be too big, and it had an error parsing that line that had the too big, the time that was too big. So you see we can gracefully handle exceptions using the throw and the try block to catch exceptions. Okay. And then the file will work just as it did in exercise 2 after that. Okay. And we can enter a start time of like 1, 4, 4, 2, 1, 2, 3, 4, 5, 6 zeros. 1, 4, 4, 2, 3, 3, 2, 0, 2, 5. And it should work like it did before with all the good data that we got and display everything properly like it did before in assignment 2. Okay, so I did a lot of work for you. I hope that helps you understand the basics of these last few assignments. Okay, and I hope everything's going well for you these first few weeks, and I hope everybody was able to get their groups situated. So let me know if you're having any issues, and have a great week.